Thank you, Laurent. Okay, this session is going to be a little bit different. We've heard a lot of great talks. We have seen other people's concepts of how uncertainty information is generated, how it progresses through the system, how it's used in the utility industry, etc. In this session, you're going to have the opportunity to think a little bit about your own mental model. We all come from our own points of views. We're each an expert in one little piece of the problem. So the goal of this session is to think through how that affects what we think, what our mental model is, and then to communicate with other folks to share our mental models so that we all get a larger picture of the whole. And the philosophy here is that by getting a better picture, by sharing our mental models, we'll be able to push the state of the science, state of the engineering, and state of the practice forward. Okay, so first, what is mental modeling? This is actually a technique used by the social scientists. My colleague Jeff Lazo introduced it to me recently, and I found that it's really a useful way. They sometimes use it to try to understand systems in that. In this case, we're using it to facilitate conversation. It's basically a picture of how one sees a process. Sometimes we draw them in terms of a flow chart. It's very individual. So when I ask you to draw a mental model, there's not a right or wrong answer. It's your personal picture. When the individual drawing the picture is an expert, it becomes part of an expert elicitation that you then can bring together to build pictures of how processes work. Again, each of us is an expert in our particular area. So the goal in this exercise is going to be to try to bring together our own expert pictures into something bigger where we can converse. So we're going to see differences in how each of us think about the problem. And we think this is going to be useful for determining a value chain and for initializing a dialogue. Okay, here we see a picture of a very complex mental model. We're not going to go to there today. This is just to show you, when you do this at a very high level, spend a lot of time on it, you can come up with something really complex. Okay, where I was introduced to it is when we started our solar power forecasting project. This is a recently funded project by the Department of Energy of the US where we're trying to advance the state of the science of solar power forecasting. Okay, so we brought together people from various universities, government labs, there's meteorologists, there's engineers, we have forecast providers, we have folks from utilities, folks from balancing authorities, very different backgrounds. We all think about things a little bit differently. But to really advance the project, we have to understand how each other thinks so that we can pull that together. So in that case, the idea was to get the general concept of the value chain. Jeff Lazo is an economist, and his job is to try to quantify the value at the end. So that was where he was coming from. But we also need to know who's the decision makers. You see, we start here on the left, basically with weather happens. And then we progress through everything from monitoring, observations, modeling, forecasting, communication, interpretation of the communication, how it's used in decision making, outcomes, and then the economic piece. So what did we get from this? We found that everybody who did this exercise did it a little bit differently. This person was a meteorologist who does a lot of pre- and post-processing. You see things in terms of everything from data assimilation to modeling, post-processing. The decision makers and the end products are just a little piece in this person's mind because that's not what this person knows about most. A meteorologist with a more of a metrics focus. Also had something about observations, community, building capacity, bringing impacts to the users, starting thinking about how the users are going to do it, and then that feeds back, the user decisions are going to feed back into how the forecast improvements are made. A utility user knew about things like statistical models, NWP, cloud modeling, came up with irradiance forecasting, power conversion, but then got a little bit more detailed here on what's important to the situational awareness for ramp forecasting, etc., and then how they're going to use it for scheduling the operations. An economist thought through, kind of really basic on all this, but note, ended up with the dollars. I think this was the only person that ended up with the dollars. Okay, somebody who's more of a geoscientist, social scientist, management, really, thinks about it, similar to the economist, thought through the processes, thought of them rather linear, power generation, verification, and then some things here like susceptibility, a few integration, a few things about why we're doing the whole thing. A systems person, this is someone who likes to pull together systems like this, very flow charty. How they're going to pull together the observations, the models, and into an analysis, the modeling, solar prediction, post-processing, etc. And then this person's picture of how the utilities and energy industry are going to use those forecasts. Okay, my own, I configured the project and I try to show all these interactions and didn't try to get too difficult. I was trying to figure out what the end users were doing with it so that I could then come up with a better system. Okay, so the point is that we all come in with our own biases, and that influences how we think about, how we develop our own mental models. Today, the topic is uncertainty for the energy industry. And we've seen some mental models already. Alberto put this one up first thing this morning. And when you look at this, a lot of this kind of formulates how he's organized this particular symposium. We've had great talks on observations, modeling, how it's being used, transfer functions, people who understand the decisions at the end. This has all helped each of us bring up the state of the system in what our own mental models are. Laurent came from a very different point of view, okay? And I know this wasn't really a mental model, but you can see how, the demand, the renewable variables, et cetera, here on the right, things like resources, power plants, energy storage, et cetera, interconnections. And then in the middle, we have this power system context. So things like power market, system operation, grid hardware, that's the way he thinks from where he sits. So, what we're going to do now is I'm going to ask each of you to develop your own mental model. Okay? Don't want something overly linear. I just want to know how you think about the uncertainty issue, where uncertainty happens, where it propagates, and how the end user deals with that level of uncertainty. When we each came in today, we were handed a paper pad, so feel free to pull out the paper pad, the pen that you were given. If you happen to prefer the one you brought yourself, if you are very, very good at coming up with computer-generated plots fast, we're only going to have about 5 minutes or so to do this. Then we're going to break out in groups and discuss our mental models. So, can we have the lights back up now? The AV folks, if we could have the lights back up, and I'll ask each of you to just pull out your paper pad and sketch your mental model of this uncertainty between meteorology and energy process. Okay, so I'm going to be quiet for a few minutes.